So what do we have here?
So what we have here is a mobile medical measurement platform. So what we wanted to do was, in a lot of cases, you want to be able to take medical measurements of patients after they leave the hospital. And it's a lot of times inconvenient and very impractical to send home a full SpO2 machine or a full ECG machine and that sort of stuff to record it. So what we've done is develop a very low cost, very, very portable platform. It's actually a lot larger than the production version is going to be here. But we're able to actually capture SpO2 and ECG right now. Respiratory is going to be implemented in the future, and it sends it over Bluetooth to a mobile device like a tablet or a phone or even a PC, and then we're able to relay it from here. We're able to go into the settings, and we can actually connect to a hospital and relay that data back to the hospital. So that's basically the summary of what we've accomplished here.
Okay, so mobile medical measurement platform. So you said it measures ECG signals. Can it go further? Like what other types of signals can it measure?
So this is ECG over here. This is SpO2 over here.
What's SpO2?
SpO2 is blood oxygenation level. So the percentage of blood oxygen the percentage of oxygen in your blood. And this last one here is the respiratory waveform, which isn't implemented. This is just a placeholder right now.
Okay.
Yeah.
So these are not real data. They're simulation data.
It's coming off of this guy right here.
Are you serious?
It's off of me right here.
Oh my god. Yeah. So can you put it on me and like the data changes?
I'll take this off. See?
Okay. Oh wow.
You take the hand off.
Okay.
Yeah.
And put it back on?
Yeah, it's a long time constants in the system, so it takes a few seconds to stabilize, but it'll come back in a few
So it's
seconds.
real-time data?
It's real-time data, yeah.
Good. And how is it different from current products in the market?
Well, the issue with current products, there are some small kind of portable applications, but they only do kind of one or the other. What we've done is integrate several of these applications into one, and like with ECG, SpO2, and respiratory and so forth. And also extremely low cost. Our production cost is way lower than what's out there.
Do you have any estimate of how much would be the production cost?
Production cost, under $100.
$100? Okay. Okay. Wow. And I think what's most cool about this is it connects up with digital devices.
Yeah.
Because
well, one of the things that's great about that is its primary purpose originally was for remote monitoring, but it gives, even with a small device, the ability for healthcare professionals to have comprehensive data analysis locally as well. You don't have to use it at the hospital side at all. It can just be used as a standalone medical device.
Okay. Okay. What did you partner up with for the research? Your partners?
In terms of, well, this is our group here. That's us. That's about it. We got some supporting help from Dr. Eklund, and obviously our campus advisor, Dr. Stein.
Okay. It's a lot of signal processing.
Yeah, we actually don't have any signal processing running yet. This is all raw data. Sometimes it goes out of sync and stuff, so there's definitely some refinements to do, but the actual functionality is complete.
Before we end, just tell me, because in high school, I'm a first-year student, and I don't know how this works at all. When he puts on the oxygen cap, how are you capturing oxygen levels?
Okay, yeah. So
what's the mechanism? What's the science?
So inside here, there's actually a couple of LEDs. You can't tell that there's two different colors.
Yeah.
But there's actually a red one and there's an infrared one, and they switch back and forth about 500 times a second.
Okay.
And what we do is we sample them back and forth, and that creates an interleaved data stream, which just basically means that we actually have two full waves, one that's captured infrared data and one that's captured red data.
Red data, yes.
And what we do is we basically take the ratio between those two, and basically the amount of absorption of light of those relative to those two wavelengths through calibration curves allows us to figure out what the actual blood oxygenation level is.
It's smart. It's smart.
It's very, we didn't come up with this.
Okay.
One of the things that we're working towards is that this is an industry standard sensor. We didn't try to make anything that was out of the box or anything abnormal, so that this can be deployed economically with current use stuff that medical professionals use every day.
The innovation you made was this platform.
Yeah, it's integrating all these different devices, making it extremely mobile, and making it extremely economical. The cost is way lower than we had before. And then just one thing that was kind of interesting, we were able to double our estimate on battery life. This can run like this, transmitting data for about 48 hours continuously.
Okay. Because one application I can think about is, say, there are children and they're ill, right? And they have a sensor put on them, and it maybe wirelessly communicates the sensor data to the CPU platform, if you will,
Yeah.
and then that analyzes it and then syncs with the smartphone of the doctor, the nurse, the healthcare
Absolutely.
professional.
One of the things we're working with is exactly that purpose. It's for remote monitoring from the hospital side, and to be able to connect back to the hospital and relay this data real time back to the hospital.
Extremely low cost. That was the main objective.
Low cost and it's mobile.
It's highly portable, and it's comprehensive. It captures all the necessary data, the different types of
The
waves.
production model wouldn't be any much larger than a cell phone.
Can you give me a brief outline of like the hardware you're using?
Sure. So, there's basically
Looks fancy.
four main blocks. This
Yeah.
is just a power supply.
Okay.
So it takes the varying battery voltage. The voltage changes over time
Okay.
as the battery is discharged.
Okay.
And it generates the fixed voltages we need for the system. This is the ECG amplifier here. So it takes the incoming ECG signals, does some basic amplification, some basic processing.
Good.
This here is a transimpedance stage and a filter for the SpO2 signal, because we're getting very small current signals.
Yes.
And we actually need a sample voltage signal. So it converts those current signals into voltage signals and sends both the ECG amplifier and the SpO2 amplifier, basically send it to this guy, which is a medical grade analog to digital converter.
Yes.
So it converts those to digital signals, which are sent over this communication bus to a microcontroller that basically does some preliminary data handling and stuff like that.
Yeah.
Sends it to this Bluetooth module, and then this Bluetooth module will send it over to the mobile device. That's basically it. I mean, in really simple terms, there's a lot going on, and it's fairly complicated to get to that point, but the actual premise and the actual architecture is really straightforward. I can also show you here that all of the actual device controls are on the wireless device. We're not having any hard controls here.
Yeah.
So you can go ahead and connect to the device and stop it. So I can actually issue a stop command, and we'll jump back here, and you can see the data is actually paused, and you can actually take a look at what's going on and see something.
Wow. So you can control it from.
Yeah. So the whole idea is all your controls and settings and stuff are all controlled from the mobile device.
What makes me wonder is what like operating system are you using, or like what programs?
It's all on Android. So it was coded using Eclipse and Java.
Eclipse and Java. Okay.
So
Language is Java programming language.
absolutely. Yeah.
Okay.
It's standard Android programming. So the library we're actually using is a third-party graphing library because Android does not come equipped with the graphing library integrated with it. But we were able to integrate a third-party graphing library, and through some minor signal processing, we were able to take the signals over Bluetooth and plot them visually on screen.
Good. Perfect.